It's important, in my view, to differentiate between foundation models and agentic systems. And I'll start with a bit of a definition. Daniel, I think there's probably a few of these out there, so feel free to disagree if you disagree. But I think for me, the foundation model is really a general purpose model that has a variety of different capabilities and can answer a whole range of different questions. It's trained on, and can be one, can be several different data sets, but it really acts as a general purpose capability. But it's not specific to one particular task. For me, the agentic system is a system which takes those foundation models typically, may also take other models that are not necessarily foundation models, and integrates them into an orchestrated set of tasks, which is designed to achieve a specific outcome.
When people ask me what's for me agentic AI, I always say it's, for me, an agent consists of three different parts. One is the foundation model or the large language model in general, and there are multiple ones out there, and it's great that you are working on your own one here. Second one is for me the context, right? Where is this model then operating in, and not just the context that get learned with, but also maybe additional context, which is outside of the foundation model, which also includes memory, company knowledge, reg, all this kind of stuff that we normally use as technology to make them more aware of the specific context these agents should operate in. And then the third layer, at least for us, this was the game changer layer, was this kind of access to tools, so that they are able to control applications that we normally use to finish a task.
If you go to the large language models today, which at the end of the day are nothing more than sequence predictors, they actually tend to do a very poor job of dealing with this. And it's really two reasons. One, they're not great at dealing with time series numerical data. And the second thing is they were never really designed to estimate, if you like, calculations on the basis of physics equations, which of course is at the heart of everything that we do within engineering. And so for us at Applied Computing, what we've been trying to do is really rethink the paradigm of how do we integrate those different data sets, those different sets of information is probably a better way of putting it, into a new type of model that you can use as a foundation to build these agentic systems.
So one use case, for example, that we see in the automotive space is, for example, when a tier supplier wants to make an RFQ for an OEM. Normally, when they got a request from the OEM for a quotation, they have to involve, I don't know, 5 to 20 experts to make sure that they can fulfill all the requirements and all the stuff. And there's a lot of different tiny tasks to do. They are normally not making a huge new development, so they're adapting a lot of things, so they are not starting from scratch. And these are the cases where I think these systems already have huge, they reach already the feasibility. So we see it already in action, people have it. And what we also see is that the business impact is already, far more than we expected, right? Because if you are in this area where you, for example, able to make the RFQ process more efficient,
a lot of the energy units that we rely on, so in refineries or in LNG plants, for example, they tend to use something called advanced process control. And what that does is it effectively optimizes the set points within the engineering limits for the operation of that facility. So in other words, it will dynamically optimize what the distributed control system is doing to maximize the throughput within the limits that have been defined. Behind that technology tends to be a set of non-linear solvers, mathematical equations that calculate those optimal set points in real time.